All right, so we are continuing section R.8, and this is the second part. Hopefully we'll be able to finish R.8 today, all right? In the lesson plans that I gave you, I think tomorrow I have planned just to basically answer questions over today and yesterday, all right? So I will assign something today. So we'll use tomorrow to answer some questions, and on Friday we're having a quiz on section R.8, okay? It's on the lesson plan thing. It's on RenWeb. It's that would be Friday, would be the quiz. Okay, it's on the lesson plans, so look at it. And we are still up to date. What's that? I don't know if I can promise I'm going to do it every single day, or every week. But I'm going to try. All right. So what we're going to do is rational exponents. So let's write that down. Uh-oh, why did it do that? Oh, because I switched. Got to do this. Got to do this. Okay, now it should work. We'll start off. Why did it do that? Well, it's because it's not writing. That's why he can't read it.
Can we turn off the light?
No, it's fine like this. All right, so let's see if that works. Yeah, that works. Good. All right. Let's rational exponents is what I was going to write. Here we go. Rational. What's that word rational? What word is inside that word rational? Ratio. What's a ratio? What's a ratio? A fraction, okay? I've said that a bunch of times. So a rational number would be a fraction. So what we're going to do, we are going to do rational exponents. So what does that mean? Rational exponents. We're going to have exponents that are what? That are fractions. Exactly. Okay, so we're going to have exponents that are fractions. So let's start off really general. I'll just use a letter A and put 1 over n. See that 1 over n? That's an exponent, isn't it?
Is that like where the square is?
Yeah, just watch. Okay? So this is a to the 1 over n power. This is an exponent. Everybody see that? The 1 over n, and it's a fraction, and it's an exponent. That's why we call this rational exponents, because our exponent is a fraction. Instead of squared or cubed or to the fourth, okay, it could be to the what? 1/2, right? Or the 1/3 or something like that, okay? We could also, we're going to learn in a few minutes, we're going to learn it could just not be to the 1 over something. It could be to the 2/3 or the 3/5 power, okay? Real weird stuff like that. But we're going to show you how to work with that. So a to the 1 over n can be rewritten like this. I'm going to put an a inside of here and an n on the outside of this. So this would be the nth root, nth, the nth root of a. That's what this thing means right here. All right, so let's put that in a box. So that's kind of our definition of a rational exponent. So if you have a to the 1 over n, it can be written as the nth root. It's not always square root, okay? It could be a cube root, fourth root, fifth root of whatever this base is. This is your base. Do you remember what we call that thing inside of the radical? The radicand, okay? So that base is going to be our radicand. Everybody got that? All right, so let me just say this. If n is an even number, okay, 2, 4, 6, 8, 10, whatever, okay, if n is an even number, you cannot have a negative inside of that root. Did you hear what I just said? If n is an even number, so if this is the second root or the square root or the fourth root, sixth root, eighth root, 10th root of whatever number, this number right here cannot be a negative number. Okay, for instance, let's just do a regular square root. We talked about this. Did I talk about this? I think on that example 5, I think I might have talked about this if you watched the video on it. So this is the square root of -4. What is this asking you? It's asking you what number, times itself is equal to -4. Is there something times itself, the same two exact numbers multiplied by themselves equals a -4? Can you have a negative anything? Why not? Because if I have two numbers that are the same numbers and multiply together, what's my answer always going to be? It's always going to be a positive number. Agree with that? Okay, so there's no way I can take two of the same exact numbers, multiply them together, and get negative anything. Agreed? All right. That also works if you had a fourth root, because a fourth root, it's an even number, right? So there's no way I can have four numbers exactly the same signs equaling a negative answer. With me? Can you have it with an odd? Can you have the third root or the cubed root of, let's say, -8? Can you have that? Is there a number multiplied by itself 3 times that equals -8? What is it? It's -2. It's not just 2, because 2 times 2 times 2 is +8. We want 3 numbers that are exactly the same multiplied together that equals -8. Can you have that? Yeah. So you do have some restrictions on this. They write the restrictions in the book. You can, and I put it in my notes too, but I thought I'd just talk through it instead of write it down, because sometimes writing it down confuses people.
When you have that equation, like -4, what do you write for that?
You can't do anything. It just doesn't exist. Right? It doesn't exist. Well, it kind of does. Later on, you just won't. You can't get an answer for it. I'm not going to give you this. Okay? Not right now. Eventually we will. Okay? It's called imaginary numbers. Did you do imaginary numbers in Algebra 2? Yeah. So it kind of exists, but not as a real number. Let's just say that. Okay? It does not exist as a real number. All right, enough of that. Let's do some examples. Let's do that rational exponent thing. Okay, we're going to take our exponent, we're going to make it a fraction. Do you remember what we do with this? We take the root. What goes inside of that root? The base, right? Remember that? The base goes in here. And what root is it? Remember, this is 1 over n. This is the nth root. So what would this be? It'd be 2. When it's a 2, do we really need to put the 2? We don't need to, but you could if you want to, all right? There's just no need for it. But what is this? This is the what? The square root of 4. And you can actually get an answer to that. What is that? What's the square root of 4? It's just plain old 2, all right? With me on that? It's actually plus or minus 2, but we're not going to do it. We'll just keep it. Because, yeah, like if you had 4 to the 1/3, like that, then how would you write this? You'd write the third root or cubed root of what? 4. Now you can't, that doesn't come out even, all right? It doesn't come out to an integer number, so you can't do anything else with that, but you could write it like this if you wanted to. Aiden? Yeah, well, we're going to do that in a second. Okay, this is only the first one. Remember, each one has 4 different parts to it. This is just the easiest part right here. Did you have a question, Matt? Okay. All right. So are you okay with our little formula? It's not really a formula. It's kind of a definition. All right, right there. So a to the 1 over n is equal to the nth root of a. That's what we're doing right here. All right, let's do another one. That was part A. This was part, oops, daggone it. Now I messed everything up, didn't I? Tell me when it's even. About right there? Okay. So this was A, and this was nothing. I just made that up. All right, let's do B. B is 8 to the 1/2. All right, it's to the 1/2 power again, so that shouldn't be that big of a deal. Now, if it's to the 1/2, do we need to put the 2 there? I think we're okay with not putting the 2, aren't you? Because when I have something to the 1/2 power, what is it? It's the square root of that number. So basically, it's the square root of 8. Do we just keep it the square root of 8? I think this was example 5. All right, so what we're going to do is break it into this. We're going to break it into 4 times 2. And I think example 5, well, I don't know. I can't remember what example it was. But we have a rule that says if you have 2 things multiplied together underneath one big square root, we can break them down into their individual square roots like this, okay? And then we can simplify that. So why did we do this? We did this because we can simplify the square root of 8. What is the square root of 4? It's just a 2. Can we simplify the square root of 2? No, so you just keep it the square root of 2, and then that's your answer. That's what 8 to the 1/2 power is. What do you think? It's not so bad, is it? All right, yeah, it's pretty easy. But just wait. Seems like it's always the way it is in math, right? You learn it the first time, you're like, I think I could deal with that. And then they always make it harder. Well, that's just the way life is sometimes, I guess. So negative 27, that's in parentheses. And then this is to the 1/3 power. It's pretty much the same as these other ones. Instead of to the 1/2, it's to the 1/3. So we put our little root here, okay? Because when it's to a fractional exponent, you're going to have a root. What's our little number out here? What's our index, we call it? It's 3. So this is the cubed root of what? Negative 27. Let's see if that simplifies. Is there anything multiplied by itself 3 times? So 3 of the same exact numbers equals negative 27. Justin? Negative 3 does. That's right. Okay, so negative 3 is your answer. So negative 27 to the 1/3 power is the same as just negative 3. You understand how we got from the exponent to the square root thing? Not square root, but to the radical? All right. Just went through that little rule, that little definition that we gave. Here's another one. 16 to the 1/3 power. So write that down. What do you think this is going to be? Well, it's a fractional exponent, so I know I'm going to have a root. What's the index? What's the little number out here? What root is it? It's the 3rd root, right? Because whatever is right there, that's what root it's going to be. And then what goes inside of here? That base, which is 16. Cube root of 16. Does that come out even? Is there something times itself 3 times that equals 16? 4? 2 is 2? No, because 2 cubed is 8. 4 cubed is not 16. So is there an integer? Is there a whole number? No, there's not. But guess what I can do with this? I could break this down into what times what? You could do it like this. Watch. I'm going to go off to the side here. Right. You should be able to figure out 8 times 2 because I know what the cube root of 8 is. I just did it up here, right? I know what the cube root of 8 is. So you should be able to do that in your head. But let's say you can't figure this out in your head. Here's a way that you could do this, and this would work pretty much every single time. Okay, sometimes when the numbers get really big, you just can't think of it in your head. Sometimes you're going to have to write it down. So what I'm going to do is I'm going to break down 16 into its prime numbers. So what times what is 16? Okay, let's go 4 times 4. Let's break down 4. What do you get? You get 2, and then you get another 2 and another 2. Now I'm trying to take the cube root, aren't I? So I'm going to group these. Am I going to pair them up? What do you think I'm going to do? If I'm going to try to take the cube root, I'm going to do what? I'm going to group them into 3s. All right? So really, it's 8, but I'm just showing you. 2 cubed is 8. Would you agree? And then times what? To make it 16. You got to have that other 2 here. See what I just did? Why did I group it into 3s? Because I'm taking the cube root. I'm trying to find what number times itself 3 times, right? That's why I grouped it in a group of 3. It's going to equal whatever. So that's how I write that. Do you remember the square root? I'm sorry, I put square. I forgot that cube. That's very important. Put the cubed right there. Okay, yeah. Sorry about that. So the cubed root right here. So the cubed root and this cube, what happens to this stuff right here? Let's write it out, okay? The cubed root of 2 cubed. And then I'm going to write the cubed root of what? Just 2. See what I did? Everything inside of that root, I just broke it down into their own individual roots. Let's move this up a little bit. Now, you don't have to go through all the stuff that I just did right here, okay? I'm showing you every little tiny step. You could have done this in your head. You could have just looked at this and said, oh, 8 times 2. I know the cube root of 8, it's 2, right? You could have done that, but I'm just showing you what's going on inside your brain, all right? It's this stuff right here. This is what's going on. So what happens if I take the cubed root and the cube, they cancel each other out. What am I left with here? Just a plain old whole number 2. What about this? Can I simplify that? Nope. So I just write it, the cubed root of 2, and that's your answer. That's what 16 to the 1/3 power is. It's 2 times the cube root of 2. So that was a little bit weird, right? But, if you understand how to break that thing down, that 16 down, don't leave it like this. Because if you leave it like this, I'm going to write simplify on a test or a quiz, and you're going to get it wrong, okay? So if you leave it like this, there's going to be an X by that number, all right, because it's not simplified. You always need to simplify these things. You good with that? All right. Now, let's do, that was example 6. I don't even think I said that. Thank you. Let's do example 7. Actually, before we do example 7, I got to write down another definition, kind of like what we just did. A to the m over n. Now, this is a little bit different. This time we have a numerator. Instead of a 1, okay, we had a numerator before, but instead of 1 as our numerator, now we're going to have a different number. So it's a to the m over n. That should be a little smaller. That's your exponent right there. So what in the world are we going to do here? Pretend that m wasn't there and that was just a 1. How would we write this? What would we stick in here? We'll put the a here and the n here, right? But you got an m on the top, so what we're going to do is we're going to take that whole thing and we're going to take it to the m power. So that's our definition. Write that down, stick it in a box. There's the box right there. Let me just show you how to do this. Now we're going to do example 7. I think sometimes it's just easier just showing you how it works. So this is example 7a. So it's 4 to the 3 halves. Aiden, this is the question that you had asked, okay? So what are we going to do with this? Well, we're going to make a root. What's our index? What's our root? Is it a square root? Is it a cube root? What is it? It's a square root. So you could put a little 2 right there if you wanted to. Since it's a 2, you don't really need it there, but you could put it there. What goes inside here? What's the radicand? So 4. Now, what do we do with all this stuff? Put in parentheses and put the cubed out here. That's exactly what we do. You understand how that fits this? All right, it's just a definition, all right, on how to simplify this stuff. Now, let's figure it out. We always do what's in parentheses first, right? So this is just a square root of 4. What's a square root of 4? It's just 2. Now, what are we doing to that 2? You're cubing it. That's right. You could put that in parentheses, but do you really need it in parentheses? You don't really need it in parentheses in this situation. So what's 2 cubed? It's 8. So 4 to the 3 halves power is the same as 8. We good? Questions? I have questions. Why do some people have their head on the desk not paying attention? That's my question. I don't know if that can be answered. Maybe that's one of the unknown answers, just like that square root of a negative number. 4 over 3. All right. Go ahead and try that one. You've got enough information now to be able to do that. No, you wrote it down in your notes, right? Did you? Why didn't you? I wrote it down. You should write it down. I'm not trying to be a jerk, but really, but really, I mean, I wrote it down, stuck it in a box. You should have written it down. You're welcome. You know it's going to be a root because you got a fractional exponent. What's the index of your root? What root is it? It's the third root. It's the cubed root. Okay. What goes inside of here? What's in the radicand here? It's a -8. Okay. And what do you do this? You take that whole thing and you take it to the 4th power. We good? All right. We can do this part right here. We've done this a couple times already just today. The cube root of 8, or this time it's -8. We did that before earlier today. It's -2, isn't it? So the cubed root of -8 is -2. Now what are we doing with that -2? Taking it to the 4th power. Notice I put this in parentheses here. Why did I put this -2 in parentheses here and I did not put this 2 in parentheses? Because this is negative, right? You're taking the whole entire -2 and taking it to the 4th power. right here, it's just a positive 2. Did it really matter if it was in parentheses or not? No. This it absolutely does. If it was not in parentheses, then your answer would be negative 2 to the 4th. You with me? But this is the quantity negative 2. My professor in college always told us to say that. When it's in parentheses like this, say the quantity negative 2 to the 4th power. That means it's in parentheses. So what does that mean? It's negative 2 times negative 2 times negative 2 times negative 2, 4 times, right? So first of all, what's the sign going to be? If it's to an even power, it's going to be positive. What's 2 to the 4th? 16, and that's your answer. So really, that's not much harder, is it, than doing the other one? All right, we just take it to another power. We take it to whatever that power is. Okay? Yes, so far so good. Ooh, look at this one. This is crazy. 32. They didn't tell you how to do this, but I'll give you a little hint. It's supposed to be an exponent. Kind of looks just as big as the 32. I should have made that 32 a lot bigger. 30. There we go. That's your exponent. To a negative exponent. What in the world do we do with that? We've talked about negative exponents before, right? We had a quiz, had a test on it, and all that kind of stuff. But this is maybe a little bit different. So here's what I'm going to do. Let's see what I did in my notes, first of all. Make sure I do this right. Okay. So what I'm going to do is this. I'm going to write. Now, they didn't show you this in the book. I'm showing you this as an example. Okay. To the, actually, do I need to put that in parentheses? Yeah, let's put it in parentheses. 32 to the 1/5. When you agree, this is to the 2/5, and it's negative. I understand, but I'm not done yet, okay? So this is 32 to the 1/5. How in the world do I get my exponent to be a negative 2? Well, I can take that whole thing and take it to the what? To the negative second. Would you agree that that and that are the same exact thing? Remember what the rule is for exponents? If you have a power taken to another power, what do you do with those exponents? Like if I had x squared to the 4th power, what do you do with those exponents? No, you don't add. You multiply them together. So what would this be? This would be x to the what? 8th. So would you agree that 1/5 times negative 2 is the same as negative 2 over 5? Why in the world did I do that? I did that to make life a lot easier for us, because I can figure out what 32 to the 1/5 is. And then I'm going to take that number and take it to the negative second power. So what in the world does that mean, 32 to the 1/5? Well, it means the 5th root of 32. Would you agree? Right? It's the thing we just learned today. That whole thing is being taken to the negative second power. Why do I do that? If I'd had my mouse hooked up, I can't get this to go even. There, that's close enough. So what's the 5th root of 32? What number times itself 5 times is 32? 7? 7 times 7, 5 times? It's got to be a little number, right? 2. 2 is. All right? Let's go through it. 2 times 2 is what? 4 times 2 is 8 times 2 is 16 times 2 is 32. That's 5 times, okay? Would you agree? So the 5th root of 32 is just a 2. And this is to the negative second power. What in the world do we do with a negative second power? Yeah, you're going to flip it, right? Remember that? If you have a negative exponent, you can either flip it to the bottom or flip it to the top, depending on where it is initially. So right now it's on the top, so what am I going to do? I'm going to take that 2. I don't even need the parentheses there. And I could put a negative 2. What's left on top, though? What if I take this and flip it to the bottom? What's left on top? A 1, right. I'm sorry. Why did I put negative there? When you flip it, what do you got to do to the sign? You get rid of the sign. You change the sign. Sorry about that. So when you flip it, you change the sign. So I flipped it to the bottom, changed the sign to a positive. Now it's really simple. What's this? 1 over 4. That's how you do that. So this was definitely a little trickier, for sure. Okay, but I gave you a nice little way to do this. So what I did is I broke it into 32 to the 1/5, and I took that to the negative second power. And then I went through and I did that whole root thing. all right, the thing we just finished learning. And then this is something, this negative exponent, we learned that earlier. You see how all that stuff builds? You understand why it's so important to learn stuff early? Because you're going to use it later on. All right, that's why it's so important to learn stuff earlier on and not just blow it off. All right, I'm going to leave that. You can go back and watch the video if I went too fast or anything like that. Let's do another one. 25. This is actually a little easier, I think. To the 6/4. Now, you could, if you wanted to, say, don't write this down. Okay, this part right here. Don't write this down. You could say this is the 4th root of 25 and then take that whole thing to the 6th power, couldn't you? But the 4th root of 25, I have no idea what that is. Okay, I'm not going to do that. That's why I said don't write it down. What do you think you could do with this 6/4 before you do anything else? Just reduce it, simplify it. That's right. Okay, just simplify the fraction. Instead of 6/4, what does that reduce to? 3/2. Now, that was the hardest part of that whole thing. And that wasn't even that hard. Now we can do what we did before. You could do that whole root thing, but I kind of like what I did earlier. Take it to the 1/2. Watch this. They don't do this in the book. There you go. 25 to the 1/2 to the what? To the 3rd. Would you agree that's the same thing? Yeah. If you wanted to go straight to the root, you could, but sometimes that can be helpful just looking at it. I kind of know what I'm going to do here. What's 25 to the 1/2? That's the square root of 25. So really, if you were, struggling for time, right, there's no reason to write a square root of 25. You know what this means right here, don't you? You know that means a square root of 25, which is 5, right? And then the 5 is being taken to what? The 3rd power, right? Because everything in here is to the 3rd. Let's do that in our head. 5 times 5 is? 25 times 5 is? 125. And that's your answer. So that one was actually easier than part C, I think. Don't you? There you go. All right. Let's do another type. We're still doing fractional exponents. We're going to do something a little bit different. I think, actually, what we're going to do right now might be a little easier than what we just finished doing. Maybe. I don't know. This is called simplifying expressions with rational exponents. I'm not going to write all that down. I'm just going to say simplify. Okay, we're going to simplify, put too many dots there. Okay, simplify these expressions. So let's just do this. Example 8a. And again, there's 3. Yeah, there's 3 examples with this. So write this down. Anything I write up here, you should be writing down. I shouldn't even have to tell you. So this is a little different. But again, we're going to rely on stuff that we learned earlier. And that's why, again, it's so important to do that. All right. Where in the world do we start? Well, I see this parentheses being taken to an exponent. So I'm going to take that exponent to everything in that parentheses. So really, this first one, I'm not going to mess with it just yet. So I'm just going to leave it the way it is. X to the 2/3 times y. Now let's do this. Remember, we just learned, well, we didn't just learn it. I just reviewed a rule that you should have known some time ago. Remember, we said x to the, I don't know, I'll make a different number. X to the 3rd to the 5th. What's x to the 3rd or x cubed to the 5th power? What's that? X to the what? Oh, come on, you're scaring me. We just finished doing this like 5 minutes ago. What do we do with the exponents? A power to another power. What do we do with the exponents? So what is it? X to the 15th. Okay? You didn't forget that already, did you? Apparently you did. Okay. So it's x to the 15th. So I just did that. These actual numbers have nothing to do with this. Okay, it's just that process. What do we do with this then? X to the -2nd to the 1/2. What do we do with this? Come on. What did we do with these numbers? Did we divide those numbers? Okay, we multiplied them. So what do we do with these numbers right here? We multiply them, right? Okay, let's do that off to the side. If you can't do that in your head, you should be able to do it in your head. But if you can't, let's do it off to the side. So this is This is off to the side, okay? So it's negative 2 times what? 1/2. Why? Because when I have a power taken to another power, I multiply those exponents together. All right, that's why I'm multiplying these together. So what do we get here? Negative 2 over 2, which is negative 1, right? So this is going to be what? X to the negative first. See what I just did? All right. What about this? That y is y to the first. So what's this? Y to the what? We don't even have to go off to the side on this one. It's just to the 1/2, because 1 times a half is a half. So first thing you do, you look to see if you have any exponents on the outside of the parentheses. Okay, it's not distributive property. Almost said distribute through. You don't really distribute it through. It's not distributive property, but you do take everything to the 1/2 power. By taking a power to another power, you multiply them together to get your new exponent. Okay? Now, what do you do with this? What can I multiply, or do I just leave it like this? No, I'm not going to leave it like this. What if you had this? What if you had... Nah, forget that. Let's just do this. You can multiply the x's together. Everything's just being multiplied, right? Okay, I think I will do this. What if I had this? What if I had x to the third times x to the fifth? Again, I'm just going back in time, back to Algebra 1, just to review this basic skill, because we're going to use that skill right here. But it's a little different because you got a fraction, all right? I'm just doing with super easy numbers. If I multiply these together, what do I get? I get x to the 8th. Why? What do we do with the exponents here? You add the exponents in this situation, okay? So when you multiply these together, you add the exponents. Got it? So now, what are we going to do with this? We're going to multiply x to the 2/3 times x to the negative second, correct? Let's do the y's. Let's write the y's down. So I'm also going to take y, or y to the first, times what? Nobody likes to answer my questions, do they? Y to the 1/2, thank you. So how do I multiply x to the 2/3 times x to the negative first? What do? I do what to the exponents? I add the exponents together, okay? So here, this is still off the side, okay?
So you don't have to FOIL?
There is no foiling.
I know, but you have two.
Yeah, but you don't have a plus sign or minus sign in between. This is not FOIL. Okay, FOIL is if I had 2x plus 1 times 3x minus 2. That's FOIL. We don't have that situation here. The only thing that's happening here is everything's being multiplied together, okay? The only thing I can combine are the ones that have like terms. It's not really adding like terms, but that's the only thing I can combine are just the x's, and I combine the y's. That's why I stuck them next to each other here and stuck them next to each other here. Make sense? So this is not FOIL method right here. Good question, though. What do we do with these exponents? Add them up. So 2/3, you could put plus or just minus 1. But how am I going to write this if I'm going to subtract it from a 2/3? 3/3, right? Do you agree with that? That's the same thing? 2/3 plus -1 is the same thing as 2/3 minus 3/3, which is a 1. Yeah? So what do you get? This is over 3. 2 minus 3 is -1. So what's my exponent to the x? It's -1/3. See that? It's really Algebra 1 rules, but we're just tweaking it a little bit, where it's just getting a little bit tougher just because you got exponent, or just because you got fractions. It's really the only thing different here. It's just you got fractions. You just have to know how to add fractions. And you did that back in elementary school, okay? So nothing's really new here. It really isn't. I'm not just saying that as a math teacher, but truly, there's really nothing new here. So what about this? Y times y to the 1/2. Again, what do I do with the exponents? I add them up. So instead of 1, put it 2/2, and then plus 1/2. What's that? That's 3/2, isn't it? So you see why I do it off to the side? Because it'd be a mess if I try to do it up here in the exponents. So it's y to the 3/2. And really, there's nothing that you could do with that. Well, I guess there's one thing. If you left it like this, I would probably be okay with it. But if you look in the back of the book, what do you think they're going to do with this x to the negative 1/3? They're going to make it a positive, okay? So what they're going to do is this. They're going to keep the y to the 3/2 on the top. We just talked about this a few minutes ago. What do you do with a negative exponent? You flip it to the bottom and then change the sign to a positive 1/3. So I would be okay with either one of these. This one right here is probably what you're going to see in the book. So just be aware of it. All right, if you saw this, you're like, oh man, that's not what I got. Well, yeah, it is. It is what you got. Okay, it's the same thing. They just made it so you don't have a negative exponent. That's all. What do you think? All right, let's do this one. This is B. I don't think we're going to have time to go over questions on homework, but tomorrow, I have all tomorrow just to reserve just to answer questions over homework. So we'll do that tomorrow. And this is to the negative 1/3. I'm going to show you, you could do this a couple different ways. I'm going to show you a little bit of a trick, okay, to make this a little bit easier. Do you see this negative 1/3 right here? Remember what we do with negative exponent? Flip it to the bottom. So if you have everything in parentheses to the negative exponent, what you can do, instead of like flipping to the bottom, what we can do is take the top and the bottom and just flip those, and then change this to a positive 1/3. Did you know you could do that? In Algebra 2, they probably taught you that. So let's do that. So this is to the negative 1/3. The negative exponent is what I really don't like about this. So there's a way that I can get rid of that negative exponent. Flip the fraction. So what's going to be on top then? Y to the 2/3. And on the bottom, 2x to the 1/3. And that whole thing is now not to the negative 3rd power, but it's to the what? To the positive 3rd power. And you're allowed to do that. Okay, it's the same idea as flipping to the bottom or flipping to the top, changing the sign of the exponent. I just took that whole fraction and then just reversed it. Okay, put the top down the bottom, put the bottom up to the top, change that from a negative to a positive, and we're good to go now. That makes it a lot easier now. So what do we have? I'm going to write out every step. You might be able to do some of this in your head, and that's fine. Go ahead and do that. But I'm going to write down every step. So we're going to take this y to the 2/3 to the what? 3rd power. Now we have to take the stuff on the bottom and take that to the 3rd power as well. See what I did? Everything's to the 3rd power. It's not distributive property. It's not FOIL or anything like that. It's just this is to the 3rd and this is to the 3rd. And I just wrote it like that. Stop me if you have a question. All right. Let's figure out what we're going to do here. Y to the 2/3 to the 3rd. Again, what do we do? A power to another power. What do we do with the exponents? We multiply them together. Can you do this in your head? 2/3 times 3. Let's do it off to the side if you can't. 2/3 times 3. Should be able to do it in your head, but if you can't, write it out. What happens here? They cancel. So what's this going to be on the top? Y what? Squared. Right? It's that rule. A power to another power. And you multiply the powers, you multiply the exponents together to get your new exponent. I did the multiplication right here. It's 2/3 times 3 over 1. 3's cancel. It's 2y squared. Let's do this one right here. Now, you got to be careful on this one because you have a 2 and you have an x to the 1/3 all being taken to the 3rd power. You see that? So you got to do the 2 first. What's 2 to the 3rd power? 2 cubed. That's an 8. You should be able to do that in your head, right? And then you got to take, you should be able to do this in your head. X to the 1/3 to the 3rd. Again, what are we doing with those? Multiplying them together. So we're taking 1/3 times 3. What happens here? Cancels. What are we left with? 1. And so it's just x to the 1st, right? If you want to put a 1 there, you can. You don't need to. And that's it. That's your answer to that right there. That was easier than the first one, wasn't it? The trick to this was right here, that first step. Okay, when you have that negative exponent and you have a fraction, flip the fraction, change it from a negative exponent to a positive exponent. That was the toughest part. The rest of it wasn't so bad. All right, I got 2 minutes. Think I can do this example in 2 minutes? It's pretty much what we just finished doing. It's really not much different. So I'm not going to do a new lesson or a new video on this if I don't finish. You should be able to figure this one out. Over x to the 1/3 times y. That whole thing is to the 1/2 power. All right, let's do this kind of quick because I'm running out of time. 9 to the 1/2. We should be able to do that in your head. What's 9 to the 1/2? It's the same thing as the square root of 9, which is 3. Let's do the x. Let's see if we can do this in our head. What do we do to the squared and the 1/2? Multiply them together. What's 2 times 1/2? It's 1. Okay? Let's do the y. Again, what do we do with the exponents? You multiply them together. So it's 1/3 times 1/2, which is 1/6. Let's do the same thing to the bottom, because everything in here is being taken to the 1/2 power. So now we're going to take this x to the 1/3 to the 1, it'll be to the 1/6. And then you take the y, it's a 1. What do? You multiply them together, it's just a 1/2. With me? Yeah. Now, I'm running out of time. I probably won't be able to finish this. But what do you do here? What do you do with that? What if you had this? What if you had x to the 3rd over x to the 7th? What do you do with the exponents in this situation? You subtract them. That would be x to the what? -4th. So I'm not going to go through this. I'm going to write down your example. You just subtract. And it's in the book. It's an example. You can look to see what it is. So here's your homework. Homework. Section R.8, Part 2. And then you're doing 55 to 73 odds. That's it. I'll collect both of those tomorrow. Actually, please collect mine now. Please. Give it to me now if you think you're going to lose it. Okay. So I'll collect this tomorrow. No, I lied. Let me just take it today, okay? Let me take R1 today. So here's a pile. Just put it on the pile. Don't hand it to me. Put it on the pile.
Watch the video from last time.
Good.
Yeah. You too.